All right, Phoenix, I got you down. All right, you guys let me know though if Deanna gets on, okay? Not in there. Okay, just a reminder, what's due today, I'm share the screen. Y'all see my screen?
Yes.
Okay. All right. So remember, what's due today, we went over the practice review for the test last Thursday. The chapter 1 review is due, which I said I wasn't gonna take that for a grade, didn't I?
Oh.
So if you do it, I'll give you 100. I'll go back and replace it, okay? So if you do the chapter review quiz, if you just do it, I'm gonna go ahead and put 100 for it. And then your test, chapter 1 is also due today. Now remember, for the test, there are some short answer questions in there. So if like, I know one of the questions, you have to put 2 points in there. And if you put like 1 point in front of the other one and I didn't have that in there, the answer is some count wrong, but it still is right. You know what I'm saying? So don't stress too much about that because I will go back in and grade it by hand myself to check over, especially the short answer questions, because it may count it wrong and it might be right. But all that is due tonight. So you guys have any questions, last minute questions on anything? No, it looks like 15 of you have already done it, so that's good. All right. Stop sharing. Spotlight on me. Okay. All right, so we're gonna go ahead and start on 2.1 today. Even though you have your tests and stuff due today, chapter 1, but I want to go ahead and start this so that way we're a little bit ahead. Oh, you know what? I don't have the other person. I don't have Jose. Is Jose here? No. Anybody seen Jose? Anybody seen Jose? And Ursula? Gone quiet on me, guys. Jose is online only. Okay. Not there. Okay. Gotcha. All right. So chapter 2 is a shorter chapter. It's got 4 sections. The first section is a little bit of review because we've talked about X and Y intercepts already. But we're going to go a little bit more detail on that. So 2.1 is going to be called intercept symmetry and graphing. All right, so let's talk about finding intercepts. We've talked about this before, but let's see what you guys remember. So if I want to find the x-intercept, can anybody tell me how would we do that? What is an x-intercept? No? A solution? A solution to what? What kind of solution? Solution to a type of problem. Like a linear quadratic, okay? Well, tell me what x-intercept, what are you, it is another word for an x-intercept or y-intercept is a solution. Okay, thank you, Phoenix. That's what I want to know. That is the key. It's where y is equal to 0. That is the big takeaway from x-intercept. It is also where the graph crosses the x-intercept. And like Casey said, we also can call this, we call this zeros. We also call it solutions. Okay, so to find the x-intercept, you're going to replace y with 0. And if you imagine on a graph, remember I showed you guys this and I drew something like this, right? And I said, okay, tell me the x-intercept. That's there. You guys remember me doing a problem like this? And I said, tell me what the x-intercepts are. And you guys named, right? This one's -4, this one's -1, this is 2, this is 4, right? And so when you're looking at this, this means y is 0. Okay. What about the y-intercept? What is the y-intercept? Good, Casey. It's where x is equal to 0. And that's the key takeaway from that. And it's where your graph crosses, or you can also say intersects, crosses the y. How did I say this? Graph crosses the x-axis. Should say axis. And so on this one, you would say it's at -2. So this would be the point 0, -2, and these would be zeros on the x values. And on the y values, goodness. So you guys are going to have to be able to find the x-intercept and the y-intercept from a given equation, not just from looking at the graph. And the way that we do that is we literally use the information that's given. If it's an x-intercept, you're going to plug y into 0. If it's a y-intercept, you're going to plug x into 0, then you're going to solve. And you should be able to do that for any equation: linear, quadratic, eventually exponential, logarithmic, a polynomial. All different types of equations, radical, rational, all different types. I got this. Good. All right, so let's look at an example. All right, find the x-intercept and y-intercept of y equals x squared minus 4, and then graph. So who can tell me what kind of equation is y equals x squared minus 4? Y'all should be able to look at that and tell. It is a difference of squares. So what does that mean it is? What kind of equation? If it's a difference of squares equation, what kind of equation is that? Quadratic, good. All right, awesome. So this is a quadratic, so we know it's gonna look like a parabola when we graph it. Okay. So how do I find the x-intercept first? What do we say we have to replace for x-intercept? Yes, y equals 0. So where there's a y, we put 0, and then we have x squared minus 4. And we know we're solving this quadratic, and you guys just said it was difference of squares. So that means when I factor it, is going to become what? It's a difference of squares. How do I factor that? Put x plus 2, x minus 2. And then we set both equal to 0 and we solve it. So we get x plus 2 equals 0, x minus 2 equals 0, and we get x equals a negative 2 and x equals a positive 2. Okay? All right, that's the x-intercept. So what that means is when I graph this, I'm going to have one here and one here. So it can either go up this way or it can go down this way. One or the other. Now we need to find the y-intercept. So what am I going to do for the y-intercept? What do I do for the y-intercept? How do I find the y-intercept? Bless you. X equals 0. So where there's an x, I plug in a 0. So 0 squared minus 4, this one's a little bit easier. 0 minus 4 is just going to be negative 4. So on my graph, I'm going to go on my y, and I'm going to go down here to negative 4. And so this would be the ordered pair 0, negative 4. And again, this would be negative, this would be positive 2, 0, and negative 2, 0. And I can graph my parabola. So the nice thing is, if you guys really don't know how to graph something, but you know the x and y-intercept, really, a lot of time that's all you need. If you're struggling on how to graph something anyway. And I mean, from there, you can do a table of values and plug in points for your x and be able to find your y values to get a couple more points if you need to. But this one is really all you need is the x-intercept and y-intercept. Questions on this one? Questions? All right, y'all want to do one? So what is 0 squared? What does that mean? 0 times 0, right? Which is just 0. So then you have 0 minus 4, which is negative 4. Yep. All right, we ready to try one on our own? Oh, let's do. Let's see here. All right, let's try this one. Find the x-intercept and y-intercept of y equals negative x squared plus 1. Y equals negative x squared plus 1. I want you guys to try this one on your own, okay? Because there's negative area. That would do is make that one. Good. All right, so again, x-intercept is y is 0, so this is going to become 0 equals negative x squared plus 1. Now, it makes it a little bit more difficult to simplify. What you could do is get rid of the negative if you wanted to. So Caleb, you could have done that and gone with what you were doing and get rid of this negative. Or you could also move this 1 over like this. So you know, with negative 1 equals negative x squared like this. Y'all see what I'm doing? Divide by negative 1. And so you end up with 1 equals x squared. And then I'm doing the square root method. Do you guys remember me going over that? How do you get rid of x squared? Square root, square root. And remember, this will be a plus or minus in the front. So what's the square root of 1 the same thing as? Just 1. So you would get x is equal to a positive or negative 1. So that means x is equal to a positive 1 and x is equal to negative 1. Now, if you got rid of the negative in the front, meaning let's say you had negative x squared plus 1 like this, and you did want to factor it, you would have to get rid of this negative. So how do I get rid of a negative? You would have to multiply the whole thing by a negative 1. And if you did that, this would become a positive and that would become a negative, and you could have done difference of squares. Okay, so you could have done it that way, but you would have needed to get rid of the negative first. You still would have got the same answer for this. So your x-intercepts are again at positive 1 and negative 1 right here. I get that? And then your y-intercept, plug in x is equal to 0. So this becomes a negative 0 squared plus 1 equals y. A negative 0 squared is going to be 0. So you're going to get y equals 1 there. Questions on this? All right, the next thing we're going to talk about is symmetry. You guys ever heard of that word symmetry? Where have you heard of the word symmetry? Something that's symmetric. What does that mean? So even on both sides, like I know in art, you've mentioned that word, right? So if like, I like to think about it as like, yeah, equal on both sides, or imagine like your face usually is pretty symmetric. Everybody's is not perfectly symmetric, but you know, you have equal parts on both sides, right? So you can describe a graph in symmetry, meaning 3 different things, or there might not be any symmetry on the graph. Something can be symmetric on the x-axis, meaning it cuts through in half on the x-axis. Something can be symmetric on the y-axis, meaning it cuts in half on the y-axis. Or something can be symmetric on the origin, which means it's like a slant, and it's symmetric on both sides of the origin, okay? And so you're going to be able to test for that. I'm just going to kind of write this out. So this is how to test a graph for symmetry. How to test for symmetry. So the first one, a graph All right, so the two that I got, there's a third one but I'm writing on his face. A graph is said to be symmetric with respect to the x-axis if you have a point x, y, and then you notice that there's a point x, negative y. So imagine if I had the order pair 2, 3, if it's symmetric on the x-axis, then the symmetric point is going to be at 2, negative 3. Okay, because again, this is the x-axis, right? It's like mirror image you cut across. Okay, if I say a graph is said to be symmetric with respect to the y-axis, so again, so here's x, here's y, then you would roll it over here, and it would be at 2, negative 2, 3. Negative 2 would be the across the y-axis. Negative 2. So cut across the y would be negative x, cut across the x, it would be a negative y. And then the origin, when you look at the origin, both your x and your y are going to be opposite. So a graph is said to be symmetric with respect to the origin if your xy is going to be a negative x, negative y. So the origin one, if I looked at 2, 3, it would be negative 2, negative 3. It would be over here. Imagine it's kind of like the origin would be considered y equals x for the origin. Now, let me ask you guys a question. Can you have an equation that is more than one? Can you have an equation or a graph that would work for more than one?
Yes.
Yes. Can you think of one that might work? Graph that might work for more than one? Yes, Casey, excellent. A circle. So like, let's think about this. If I drew a circle and I drew one. Yeah, which we don't really do a square equation in here, but yes. Yes. So think about this circle. Is symmetric on the x-axis, and then it is also symmetric here. And this one may be symmetric on the origin. I don't have mine exact here, but looks like it would be symmetric on the origin too. Now, not all of them would be that way, but. So yeah, now can you also have one that's neither any of them? Could you have something that's not symmetric on any of them?
Triangle.
Well, yeah, but don't think about shape. Don't just think about shape. Think about an equation. What about this one? If I graph this one. In order for something to be symmetric on the x, it's going to have to be on the x. Does that make sense? It's going to have go through the x. Is for something to be symmetric on the y, it's going to have to have y going through it. Okay. And this one's definitely not the origin because there's nothing over here. So this would be an example of one that does not have any symmetry. Does that make sense? No symmetry. Okay. All right, so how do we actually test for symmetry? To test for symmetry in an algebraic equation, because we can do that in algebraic equation, you would have to actually replace, for your x-axis, you would replace y with a negative y. So notice here, your y's change. Okay, so I'm gonna write this down. Does everybody have this part down? Okay, so how do we do it algebraically? For the x-axis, you're actually gonna replace your equation where where it did have a positive y, you're gonna replace it with a negative y. And then for the y, you're gonna replace it with a negative x. And then for the origin, you're gonna replace both the x and the y with with a negative x and y. You'll see what I'm talking about in just a second. For let's see how x and tree place y and negative y. If you get if an equivalent equation, then it is symmetric on x-axis. All right, so to test, you're going to replace the y with a negative y. If you get back the same equation that you started with, then you know it's symmetric on the x-axis. All right, for the y symmetry, you're going to replace x with a negative x if equivalent equation, then it is symmetric on y-axis. Again, I'm going to give you guys some examples of these in just a minute. And then for the origin, you're going to replace both the x and the y with a negative x and negative y. So replace x with negative x and y with a negative y if equivalent equation then it's symmetric on the origin. All right, everybody got all this down? All right, so let's look at a couple of examples. We're gonna have to find the intercepts on these and figure out if there's any symmetry, okay? Like, oh, somebody said wait. Okay, A- Abigail, I can't go back and rewrite it all because it'll take forever. Sorry. I waited, I didn't understand what you said. Abigail, if you need to go back and I'm recording it so you can go back and get it. Oh, look, see, thank you guys. Look at that. It's awesome. You guys are the best. Look at that. Sometimes it's what you gotta do, you know? If I had my whiteboard and my little thing, I'd be able to just scroll back up and I wouldn't have to erase it, but I can't do it up here. You guys are the best. I know, and Casey wasn't even the one that put it up there. Oh, you guys. All right, okay, let's look at an example. We want to find the equation, for the equation, we want to find the intercept and test for symmetry. So, for the equation, find intercepts and test for symmetry. We've got y equals x squared times 4 and x squared plus 1. Pause there for a few minutes, get it right. Abigail's riding in her car on the way, on the way. So she is probably a little distracted. So Abigail, I'll slow down a little bit for you. Now, if you guys want to go ahead and try it, go ahead and try the finding the intercepts. Yeah, you're muted on my end, so I don't know. Maybe it was somebody else because I couldn't hear you, which I don't hear anybody. Oh, goodness. I'm so confused by this whole conversation. I'm very confused. Yeah, I can imagine. Keeps things interesting though. Um, my 9-year-old told me that her teacher told her that their class was so talkative that she had threatened to quit a couple times. And then she took off the next day. She was like, they talked so much, she needed a day off. I was like, well, kind of believe it. Casey said, I did mean it. Oh my goodness. He did. Oh, God. That is funny. I did mean it. Was it me? That reminds me, my, I have so many funny stories. My 6-year-old, the 9-year-old had got a new desk for Christmas, a white desk. And she went in there one night and looked, and Gray, my middle child, had written her name in permanent marker on her desk. And I went in there and I said, Gray, I cannot believe you did this. And she said, it wasn't me. I didn't do it, Mama. And she was just so serious. She was like, I did not do it. I don't know who did it. I said, Gray, you wrote your name. Who else would write their name on there? You wrote your own name. She was just lying. It was funny. I don't know. Getting out of control. Getting out of control over there.
You're just sending memes now.
Okay. All right, let's get back on track. Oh, you're driving by New York City. Well, how do I can't see your. See. Oh, look at Abby.
Oh, wait, here she is. Must be nice.
Yeah, that's pretty cool, isn't it? Pretty cool. All right. And Connor put something up there too. You guys are killing me. All right. Do what? Uh-huh, she's going to New York right now, Abigail.
Yeah, she just came back from New York.
All right. Cheyenne missed it. All right, let's get back focused, guys. We got like 25 more minutes. Okay, so how do I find the X and Y intercept? Well, how do we find the X intercept? What do we do? Replace. It was like, I just answered that last time. All right, what do we do, guys? X intercept, you gotta be able to spit it out. Replace, yes, Y with 0. So here we go. X squared minus 4 over X squared plus 1. How do I solve this? Anybody know? I'm gonna multiply both sides by the denominator. So that goes away, that goes away, that goes away. So you're left with 0 equals X squared minus 4. Now, what kind of problem is this? What is X squared minus 4? How do I solve that? Difference of squares, good. Factor it out, good. Difference of squares, so what would this be? X plus 2, X minus 2. Right? And then, got X equals, so X plus 2 equals 0, and X minus 2 equals 0, and you get X equals a negative 2, and X equals a positive 2. Okay? All right, so now let's look at y-intercept. Now, y-intercept means X equals 0. Plug in that, that's going to be 0 squared minus 4 over 0 squared plus 1 equals y. And then we get negative 4 over 1, which is negative 4. Okay, so if I'm graphing this, we got 2, 2, 2, negative 2, and negative 4. All right, now we got to test for symmetry. Graph this. A little bit like this. Graphed it, but
It's a very odd shape.
yeah, it's watching. All right, everybody got this? I'll pause.
Slot the whole thing in, definitely. Same thing you got.
And you can do the same thing. You can do that with this one.
I've been trying to figure out.
Is that what it looks like on the graph?
Yeah,
Okay.
it's pretty much the same.
Same thing, yeah. It should be.
Same coins as well.
Yeah, it should be. I hope. Because that means if we didn't get the same thing, we'd be doing something wrong. All right, I don't want to erase it until everybody's got it. Because now we have to test for symmetry. Everybody understand what we did here?
Yeah.
All right. Now, testing for symmetry. let's test for the x-axis first. How do we test for the x-axis? What'd you guys write down? Remember, you replace a y with a negative y, okay? So here's y, negative y equals this. Now, what it said is if you get the same equation back again, and it's the same as the original, then it's symmetric on the x. So if I look at this, is this the same as the original? Well, let's think. If this is a negative and this is a positive, if I wanted to get rid of it over here, then I would multiply by -1 and you would end up with positive y equals a negative times all of this. Is this right here the same as the original? Is there any way that these are going to be the same? No. I mean, they look the same except there's a negative here.
Oh, I didn't see that.
You see that? So this negative, because if I wanted to make this a positive y, which is what that is, I would end up multiplying this whole thing by a negative. And so that changes the whole thing. Does that make sense? So it's definitely not symmetric on the x. And look, you can kind of tell, right? Here's the x. There's nothing up here that's going to be mirror imaging, right? So it's not symmetric on the x. What about the y axis? The y-axis, you're going to replace the x with the negative x. So this becomes y equals negative x squared minus 4 over negative x squared plus 1. Is this the same as that? What happens then if I do negative x squared? What does that become?
Positive X.
So is that the same?
Yeah, I was looking at the wrong.
All right, what about this one?
Be same thing.
Same thing. So this is going to end up being the same as this because if you square a negative, it's still going to give you a positive, okay? So this is, yes, it's symmetric. Symmetric on y-axis. All right, now what about the origin? Do you think the origin's going to work?
No.
No, because it didn't work on this one. Does that make sense? But we can check it. Origin, remember, you replace, well, that's not always the case. You still need to check it. Replace y with a negative y and x with a negative x. So I'm going to do both. Negative y, is that equal to negative x squared minus 4 over negative x squared plus 1. All right, is this equation going to end up giving you this one? Well, because of this negative y, that one didn't work, then it's not going to work. Okay. Oh, no.
I was trying to think I could make it last.
Well, we only got 8 minutes left.
Yeah.
And you're in here, so just write the notes from the board.
It'll last long.
So is it symmetric on the origin? No, because this will end up being the same, but this negative y makes it so it's not the same. Okay, so not symmetric on the origin, not symmetric. So for this one, the only symmetry we had was the y-axis, which makes sense because if you look at it, it looks symmetric on the y, right?
Yeah.
Questions on that one? All right, let's see if we have time for one more. Let's do y equals x cubed.
You write the original pick.
Okay. I was like, we lost somebody, but it was you.
Yeah, we did. Was that 102 before? Right here. It can't last an hour.
My gosh, that means something's going on with your battery, probably. I mean, mine won't work like. I like my old laptop, I have to keep it charged all the time because it won't. Yeah, no, that's what I got. That's what I got at home is like the cheapest you could get. Cause I had to pay for it myself, so now we got laptops here, so I could use that one, but. Okay. All right, so y equals cubed, let's check that one. Just a new equation. Doing another example. Sake of time, I'm just going to do it all with y'all. All right, so let's say we have y equals cubed. My next example, x cubed, excuse me. Y equals x cubed. I want to test the x-intercept, or I want to find the x-intercept and y-intercept. So for the x-intercept, I'm going to do y equals 0. The 0 equals x cubed. Now, how do I do that? How do I solve that? Yep. So what is that? What's the cube root of 0?
0.
0. So 0 is 0. Okay. So what do you think the y-intercept is going to be?
0.
0. Because the 0 equals x cubed, and you do the cube root, and you're going to get, excuse me, x is 0. 0. Yeah. Right. So 0, 0 is the origin on the origin, and that's your x and your y-intercept. This one's going to look like this. Okay. All right, symmetry. For the x-axis, remember you're going to replace the y with a negative y. So this becomes negative y equals x cubed. Is there any way that that is going to be the same as this? Is this any way that's going to be the same as this?
No.
No.
Negative.
Negative. All right, y-axis. You replace the x with a negative x. Okay, so y equals negative x cubed. Is there any way this is the same as that?
No.
No. All right, the last thing you're going to check for is origin. Origin, remember you replace both. You replace the x with a negative x and the y with a negative y. So this becomes a negative y equals a negative x cubed. Is this the same as that?
No.
Well, check. Could I get rid of these negatives? There's a negative on both sides, right?
Yeah.
So how could I get rid of them? Divide. And they become what? Positive. Is this the same as that?
Yes.
Yes, so this is symmetric on the origin. If you check these ordered pairs on the calculator and the table of values, you'll notice like this is going to be 1, 1, and this is going to be -1, -1. They're opposites. So this is an example of symmetric on the origin. Okay? All right, that's all we got time for today. Questions? All right, tonight, if you have not done so already, make sure, get the quiz review, chapter 1 done. If you do it, I'll give you 100. And then the test, okay? Questions? Anybody got any questions? Okay. Email me if you have a question or have an issue. And again, I will hand grade the chapter test. So if there's one that you feel like you got right and it looks like it's marked wrong, again, I'm going to go back and check all of them. So I'll see you guys on Thursday.